Jim Kunkel here. Make sure that you subscribe to my channel and set the notification bell to all so that you won't miss any of my new content. Welcome to a new episode of Global Topic. Today's topic will be abrasive blasting advantages using sponge media, and today's guest will be Ed Zaharis, who is a regional manager with SpongeJet. I hope you enjoy this episode. Hey Ed, welcome to Global Topic.
Thank you, Jim. How are you today?
I'm doing very well. Thank you for joining me. Hey, I wanted to, if you could take a minute or two and explain SpongeJet and your role at SpongeJet.
Yeah, so SpongeJet was a company that was founded in 1994, so we've been around for a little over 30 years now, and I've been with the company myself for 11 years now, and we are a manufacturer of equipment and sponge media. And in those 30 years, we've grown to 104 countries globally and have learned a lot about ourselves, and especially in the last 5 or 6 years. People that were familiar with SpongeJet, longer than that, 8 years ago, 10 years ago, there were very specific things that they looked at using sponge media for, but had generally thought it's going to be very much a niche market type application. And what we've, thanks to laws and things that have changed and the things that we've learned about ourselves in the last 5 years with re-engineering equipment and the ability to learn more about correct blasting techniques, because we'll be a little bit different, that now we have the ability to compete speed-wise with grits like coal slag and garnet, and have the ability to be just as economical as what those are as well. So when we used to be considered slow and expensive, but used for very specific applications where you needed the low dust and the low rebound, we've now become much more acceptable and even have laydown yards starting to convert to the use of sponge instead of something like garnet or coal slag, because economically we can compete and because of the new laws that are out there currently.
And you're a regional manager with SpongeJet?
Yeah, so I'm one of SpongeJet's senior managers, and we'll be comprised of both regional managers, senior managers. I manage the Midwest, to which there'll be regional managers that work different states in there, and I also manage the rail industry for SpongeJet. So I'm very involved with our robotics, which is something else that we've gotten very involved in the last 5 years, which has allowed us to learn a lot about ourselves. So we build robotics both ourselves and have partnered with other companies to build robotics as well, because more and more people want to eliminate confined space entry, and you can do that through automation. And due to the low rebound and the low dust aspects of the sponge, you can put a high-tech robot with cameras and lasers and other things inside of those spaces and not destroy them because of the rebound.
So, Ed, for those who might have limited or no knowledge on what sponge media is, could you please explain the composition of sponge media?
Yeah, absolutely. So in the background that you can see behind me here, I have an exploded view of the sponge particle, and it's a urethane foam. And what we do is we'll embed a grid inside of that. And the reason for doing that is it gives us a couple unique characteristics. One, it makes it low dust. It is going to be 5,400 times less dusty than something like coal slag, for example. And I'll say that again, because people will think there's no way. 5,400 times less dusty. So it'll give you 92 to 94% dust suppression on a surface, which will give you the same level of dust suppression as a vapor blaster, but it'll be a completely dry process. The other advantage that sponge gives you is it's going to be low rebound. In the example you see behind me here, you see somebody in just a Tyvek suit blasting, and because of the low rebound, when you propel a grit like garnet or coal slag at a surface or sponge, it's leaving that nozzle at 400 plus miles per hour. When a sponge particle rebounds off of that substrate or surface, it's rebounding at about 20 miles per hour, when a piece of coal slag or garnet is rebounding at 200 miles per hour. So now it becomes safe to use around rotating parts, equipment, things of that nature. And as long as you're not directly hitting a surface, you're not going to damage it. So you have low rebound. The other thing that the sponge does is cleans that surface of invisible contaminants. So things like chlorides, hydrocarbons, low-level nuclear radiation, for example. But when it comes to prepping a surface for coatings, and you look at chlorides, what are the chlorides levels on there? Are there hydrocarbons that are on there? And so traditionally, another step has to be performed if you're doing some sort of wash or rinse to remove chlorides off of that surface, where the sponge will do it for you in one step. And even though you're recycling that sponge, we have testing that shows it does not redeposit. So you have the ability to have a nice clean surface. And SSPC, I'd always said in the past that about 75% of all coating failures are due to surface preparation. Now they think it's closer to probably 80, 90%, somewhere in there. And that's how important it is. And a lot of that is due to those invisible contaminants that aren't being removed off of the surface that sponge media has the capability of being able to perform.
Well, how is sponge media used to perform the abrasive blasting for the surface preparation? And what are the major advantages of using, sponge media?
Well, so 3 of the major advantages we had already gone through with the low dust, the low rebound, and the ability to clean invisible contaminants off it. But one of the other big advantages is it's a recyclable media. And one of the other things I put on here is the sponge blast process, that everybody could just kind of see it versus having to try to explain it. And so you have our sponge that's here, and you'll put it in what looks like a traditional blast pot, but there are 3 major differences. So you do have to use sponge equipment to be able to blast with it. And then you have a blaster. So it look like somebody who's doing, could be cold slate, could be garnet, could be sponge. It uses compressed air, just like other systems would use. And you take and you propel that piece of sponge at the surface. And as I mentioned earlier, you're doing that at 400 plus miles per hour. So what happens is that when that piece of sponge hits the surface, as you see in that graphic right there, it compresses that piece of sponge. And when it compresses, it exposes the grit that's inside of it. And we can put any kind of grit we want inside of the sponge as long as it's recyclable. It could be plastic, it could be aluminum oxide, it could be steel, it could become something called SPOC, which is a spherical precipitative calcium carbonate. So depending on what you want to accomplish, or the finish that you want to have, the profile that you want to have, we have the ability to do that. We have over 24 different types of sponge. So if there is a very specific specification, we can meet that. Most of our sponge is different grades of aluminum oxide, and by grades I mean different grit sizes. And so we don't do a grit range. So something like a silver 60 is a 60 grit aluminum oxide, or we'll have an 80 grit aluminum oxide, or a 30. So that way we can be very specific for what that coating manufacturer wants on that surface. And the reason we use aluminum oxide mostly is because it's a non-metallic. So when it comes to things like stainless steel and things like that, you have the ability to be able to use that. And it's very hard and very sharp. So even though over time aluminum oxide will fracture and it does break down, but it still retains a cutting edge. So it gives you a very angular profile. So it when it comes to adhesion, it's a phenomenal cutting agent, and that's why we use it in the bulk of what we do. And then so after you blast it at that substrate, it performs its grit action. Now when it rebounds, you've flattened out the sponge. It's like taking a sponge and gripping it really tight in your hand and putting it in a sink full of water. When you let go, that sponge is going to absorb a bunch of water. The same thing is happening with these small pieces of sponge. We call it micro containment. So again, 92 to 94% of whatever would typically become airborne is now getting pulled into that piece of sponge. And that's how we become low dust. And then when it falls to the floor, we'll take and either sweep, vacuum, however the person chooses to pick it up, and we put it in this recycler here. And that recycler will have 3 spouts on it. The top spout is large contaminants, nuts, bolts, rocks, welding rods, things that you might pick up with the sponge to go in there to get separated out. The middle spout is good reusable sponge that just goes right back into the blast pot up above here. And what happens in that process, the majority of those contaminants that the sponge is pulled into it get shaken out. And as those contaminants get shaken out, they come out of the bottom spout, which we call the fines, which is our waste stream right here. Now, every time you blast with the sponge, it breaks down a little bit until eventually the sponge itself comes out with the fines. So a person doesn't have to try to determine whether that sponge is still good or not. That recycling process will determine that for you. And the nice part about that is because it's recyclable, your waste stream is typically about 45 pounds per hour with a number 8 nozzle, compared to potentially 18 to 2,200 pounds per hour on something like garnet or coal slag.
Ed, as you know, respiratory safety regulations and increasing coating project requirements on minimizing dust, that's produced during abrasive blasting operations are changing how contractors operate. How does sponge media address regulations and these low dust project requirements?
So for a lot of years, as I mentioned in the beginning, there were certain things that we got used on more than other things. And one of those things was projects where you had a hazardous environment, lead abatement maybe, for example, or it might have been tanks that had some sort of hazardous material in it, like ethyl oxide or an MDI or TDI, things of that nature, because we kept low dust levels down. But from a surface prep standpoint, you could look at it and say, okay, use lead, for example. So often on lead projects, because 92 to 94% was being contained inside of the sponge, often those lead levels during continuous monitoring would show that you were below the action level. So now, instead of your PPE, your full face respirator, your Tyvek suit, everything that you did to protect that worker inside of containment, now became the secondary form of protection for that person. And the sponge was an engineered process that became the primary source of protection, not only for people that are inside of that containment, but also for people that are outside of that containment, because how often does containment become breached somehow during the blasting process? So now you have that. So we've been able to show over 20 plus years the ability to limit airborne emissions, especially when it comes to things that are hazardous. Now that the rules have changed, particularly with the new silica and beryllium rules, we have the ability to be able to do the same thing. And so now when it comes to grits that can't meet the silica standard, we have the ability to be able to meet that silica standard, to be able to open blast with it. We are below the EPA's AP42 airborne dust emission standard, and the same thing with the beryllium rule. So now, instead of having to do extra containment or do the things necessary or to keep from getting fined for illegal open air blasting due to emissions, a person now has the ability to come in and just be able to open air blast with a sponge and be able to be below those emission standards. So that's a tremendous cost savings that somebody gets, not having to do all that extra dust collection or containment that they are going to have to start performing.
Yeah, staying in compliance with, safety and environmental regulations and low dust project requirements is very important, but also maintaining project cost needs to be considered. Can you provide any return on investment types with, using sponge media?
Yeah, so again, as I mentioned earlier, in the past, somebody that might have looked at us 10 years ago would say, boy, this is great, and it worked perfect for what we wanted to be able to do, but it was slow and it was expensive. So again, we re-engineered ourselves, we figured some things out, so now we could compete productivity-wise, and now we have the ability with what we do in blasting, so now our cost per square foot can become similar. So it gave us a competitive edge right there. And then what throws us over the top is when it comes to things like handling material. Again, your consumption is 1.5 bags per nozzle hour. We'll have people say, can you buy a sponge in super sacks? You can, but why would you want to? At 1.5 bags per nozzle hour, you're not buying a truckload at a time. You're getting a pallet or two. And that's one of the things to get people to get used to is like, really, this is all I need? It's because the recycling you get out of 1.5 bags per nozzle hour is what you're going through. And again, when it comes to the waste stream part of it. So then on the waste stream side of things, again, that's 1.5 bags per nozzle hour is what your waste stream is. So you save tremendously when it comes to disposal costs and being able to handle all of that. And the nice part with the sponge is because it's a recyclable process to make it work, because of low dust and low rebound, you can have somebody inside of that containment who's sweeping up and recycling sponge and refilling the pot as you go along. As you see in the process behind me, it's something continuous that is always going on. So the nice part is that in a coal slag or a garnet example, you might be going in there and the guys go in and blast. They'll blast, get what they think is everything blasted. Because of the dust that you have in there, they come out, they let it settle for a while, and they look at the areas that they have to touch up and deal with, and they go in and they do their touch-up work, and then they come back out, and then somebody has to go and clean all of that up. And that's a tremendous amount of grit that then has to be cleaned up. Because you're cleaning up and doing sponge at the same time, literally when you are done sponge blasting, you can do a quick blowdown of the area to ensure any dust that is in there, because it's not zero, but it's very low, that surface is, you can go in there and coat much faster. So from the moment you go in to start blasting to the moment you can go in and start applying a coating, you now have the ability to do it much quicker with sponge because of that ability to clean up and recycle and do all of that at the exact same time. So it's a matter of changing your steps in which you do some of the things. And because of the low rebound, a lot of the containment that gets hung, if you're hanging containment to do painting, a lot of times people will use 4 or 6 mil polyplastic and cover things. You can do that ahead of time, sponge blast, and your paint containment is already up because you're not having to use heavy canvas and things of that nature to be able to do it. So it's a matter of just changing around how the process works a little bit, but it gives you the ability to be able to complete that project much quicker.
Yeah, it sounds like there is a lot of great advantage and benefits, and with all the adjustments you can make, there's definitely clearly some return on investment, and to your point, advantages and everything like that. Ed, what a great conversation we're having. In closing out our discussion, is there anything that we didn't cover that you would like to leave with the viewers?
One of the things when it comes to it is ultimately, whether it's our role, myself, or as a distributor, we believe very strongly in having partnerships with people. The process, not everybody is as familiar with the process, and we've been around for over 30 years and we've learned a lot. We've learned a lot about different applications, things go on. So we look at everything with everybody as a partnership that we do. Our job isn't to go out and find a contract and here, let's sell you something, or that's not the goal we want our distributors to be able to have, is say, oh, let's just sell you something. Our objective is to learn all the time as we go along. So more importantly, we stress on our distributors and people that go out and represent SpongeJet that their role is to provide service and support. So we become very hands-on with everything that we do. Again, because the process is a little bit different and it's not about equipment, it's about the sponge itself. In the commodities business. So we look at everything and say, okay, what do we need to do to make that contractor, end user, get exactly what they want and need out of it, so everybody comes out of it looks like a rock star when this entire process happens. So we're very hands-on with everything that we do with not only the end user but the customer, and look at everything and say, is this the right application? Is this the right type of sponge? What pressure should you use? We get used a lot in restoration as well, where you need that input because every project is a little different, and contractors look at things, and whether it's sponge or it's a different type of media that they might use, they know that. But if they had been using a different type of media over years, they've learned that information themselves. So it's very important to us that we stay very hands-on and have that partnership with people that are out there. We get very involved with NACE and SSPC. I am a NACE member myself. I'm also an ASTM member. And, our objective is to learn, how do we progress the industry as a whole? Again, it goes back to 75% or more all coating failures are due to the surface preparation out there. And our role as a company that provides a material for surface preparation, how do we do a better job of that? So we are always learning and evolving ourselves. And that's probably the one thing that I cannot not stress enough to people, that be able to use us as a resource, and whether it's us or not, our objective is to just be able to advance the industry.
If you'd like to learn more about SpongeJet Media and SpongeJet, and also to take a look at the distribution outlets that they do have globally as well. I will, in the episode's description, for the video description, I will have a link to their website. I'll also put the contact, or let's say the LinkedIn address, profile address for Ed, if you'd like to connect with him on LinkedIn as well. Ed, thank you so much for the opportunity to have a conversation with you today.
Thank you very much, Jim. I appreciate the opportunity as well. And anytime. Thank you.
Hey, have a great day.
You as well.
So, Joe, for the lay person who's watching this episode, who might only think that corrosion engineering is related to metal corrosion, as an overview, what else does corrosion engineering relate to?